Hello everyone, welcome back to Let's Crack JEE in English, the channel of Unacademy. And I'm Jeetendra Dixit. Here's my profile. Just for a moment, wait for a moment. Let me check my voice and whether I'm live or not. Yeah. So I did my BTech from IIT Kanpur and I have been mentoring IIT-JEE aspirants for last 11 years. So in today's session, we'll continue differential equations. This is the last. Yeah, voice is perfect. So we'll continue differential equations. This is the last session in which we'll do mostly exact forms. Okay, so we'll conclude differential equations today. But before we start, let me tell you about Unacademy subscription. So as you know, Unacademy is India's largest online learning platform. And once you, if you're preparing for IIT-JEE, then you can have two types of subscriptions on Unacademy. One is Plus subscription and the other is Iconic subscription. So if you are taking Plus subscription, then you'll get access to daily live classes of all the educators who are teaching on Unacademy. You can watch their live sessions as well as if you miss something, then you can watch recorded sessions as well. You can follow educators of your choice. That is up to you. You have complete freedom. So this is unlimited access which you get on the platform once you have the plus subscription. Everything you'll get. All types of accesses you'll get on the platform. So all the live tests and quizzes will also be accessible to you. And all the courses are well structured and the live classes are very interactive. You can chat with your educator. You can ask your doubts. Apart from dedicated doubt sessions during the session or during any live session, you can ask your doubts through chat. You can send images also, all right? So these are the features of live sessions which you get. And apart, these are the subscription charges. You can subscribe for 1 month, 3 months, 6, 12 and 24 months. 12 and 24 months are economically the best packages. So as you can see, 12 months in 12 month subscription per month you will have to pay only 3,200, and that too after 10% discount it is going to be 2,900 approximately. Or 12 months it will be 34,650 after 10% discount. So you can use the referral code JEET1 to get 10% discount. Similarly, it is applicable for all the subscriptions. You'll get 10% discount, but I would suggest 10 and 12 and 24 months are the best. You can compare with other subscriptions also. Now this is Iconic subscription. In Iconic subscription, you get all the benefits of Plus, and apart from that, you get a personal coach who will guide you throughout the preparation for top exams like IIT-JEE Advanced, Main, BITS, all right? And your test analysis will be done in a personalized manner. Personalized feedback will be given to you to improve your time management and exam approach. Your study planner will be customized and bi-weekly reviews will be given highlighting your progress, all right? So all these features you get once you have Iconic subscription. So these are the charges of Iconic subscription. A subscription charge for 1 year is 56,000 and for 2 years it is 86,000. So you get 10% discount in these two, and finally you'll have to pay 50,400 for 1 year and 77,400 for 2 years. All right. Now this is Unacademy's learning app which you can download from Play Store, and after downloading it you can start attending special classes. Special classes are completely free, so you get right. So special classes are completely free, so you can watch unlimited special classes on the platform. No need to take any subscription for that. These special classes are live, and all the educators take these classes. So every day you can see a lot of special classes are going on live on the platform. So you can just make your account, download this app, and start attending those classes. All right. Now let's begin the exact form. Okay. So what is this exact form? First of all, like you have d of sorry, if you have f dash x dx, then this can be written as d of fx, right? This is called exact, writing in exact form. Okay, f dash x dx, if we write f dash x dx as d of fx, then this is called exact derivative. Okay, exact form. Similarly, if you have like say fx dx, all right, f dash x dx plus say g dash x dx, all right, then you can write d of what, fx plus gx, right? You can write like this. So I'm just explaining, and then we'll memorize some specific forms like x. If you have suppose x squared dx, okay, how do you write an exact form? You can write this d of x cubed by 3, right? Because if you differentiate x cubed by 3, it is going to be x squared, all right, and dx. So you can write like this. So now these are some important forms which you need to remember. First is x dy plus y dx. So whenever you see this term in differential equations, you can write this as d of xy, all right, d of xy. Then second, I'll tell you three terms. Second is x dy minus y dx. If you have minus in between, minus dx, then in denominator it should be either x square or y square. Okay, it can be x square also. So x square, this you can write d of y upon x. Okay, if it is y square in the denominator, then you can write minus of d of x upon y. Okay, so in denominator it can be x square, y square, so I'm writing it twice. Say if you have y dx minus x dy, so you can see the difference in the numerator is only of minus sign. So divided by, you can have y square there, and it is going to be d of x upon y, all right, d of x upon y. Now the third one, these two are same, basically similar, right, similar. So now the next one is d of x dx. If you have x dx plus y dx, then sometimes this is also used, and this can be written as d of x square plus y square by 2. By 2, 1 by 2 you can write outside also, like you can write 1 by 2 of d of x square plus y square. So after converting in this exact form, you can solve the differential equation easily. I'll give you some examples. Okay, so let me give you one example. Suppose you have x dx plus y dy, okay, divided by x square plus y square is equal to x into xy whole cube. Okay, and then you have x dy plus y dx, y dx. Suppose you need to solve this differential equation. So now can you notice this in this those two particular expressions which I have written here, x dx, x dy plus y dx, this is there, right? And the second one is also there. This is also there. So we are going to use it. Okay, how to use it? See, I can write this x plus y. Is it visible? X plus y. Sorry, not x plus y. First of all, let's write this d of x square plus y square, 1 by 2, as I told you, can be written outside, divided by this x square plus y square as it is, okay, is equal to this can be written as d of xy, and take this xy whole cube to the denominator, okay, of right side expression. So this is xy whole cube. All right, now you can integrate it easily. So now you can integrate, and after integrating you can see this is going to be ln of x square plus y square, okay, ln of x square plus y square, and this is going to be minus 3 upon xy the whole square, all right, plus 3. So this is going to be the answer, okay. Now you can see after converting this in exact form, you can do it easily, all right. So now let me give you another example. Now suppose you have say x dy minus y dx, okay. Upon xy the whole square is equal to x square plus y square into x dy plus y dx, okay. Now you try this. Now you try this differential equation, then I'll tell you the solution, okay. So in the same way you can try this. Okay guys, so try this one. Are you doing it? All right, then okay, then let me tell you the solution of this. Okay, so if you write this as if you divide it by x square, if you divide this by x square and also this by x square, then this is going to be your d of x upon y, sorry, y upon x. This is going to be your d of y upon x, d of y upon x, all right? And divided by, you can bring this right hand expression, which is actually 1 plus y, to the denominator. 1 plus y upon x the whole square. You can bring this expression to the denominator and take this xy the whole square to the right side. So it is going to be xy the whole square, and write this x dy plus y dx as d of xy. So now you can see x, the function of xy is with d of xy. The function of y upon x is with d of y upon x. With d of y upon x, you can put any function of y upon x. Okay. So now you can see this is like dt. Now you can integrate it easily. Now it is like dt upon 1 plus t square. So dt upon 1 plus t square means you can write this as tan inverse t. So tan inverse of, this is tan inverse of y upon x. No need to substitute anything. Just assume y upon x as x. Okay. So it is dx upon 1 plus x square. So that is tan inverse of x. And is equal to, it is xy the whole cube divided by 3 plus c. All right. So that is the answer. That is the answer. And I hope you understood this. So let me give you another example. This is a very, very good example. Question number 3. So now you try this. X dx plus y dy is equal to x dy minus y dx. Although this is a homogeneous equation, but do not solve it using homogeneous. Solve it using exact form. Okay, I'm telling you, solve it using exact form, not homogeneous form. Getting it, Subhash? Solve it using homogeneous form. Are you solving it, Subhash? All right. Try it. This is a very good question, but do not do it using homogeneous form. Do it using exact form. Are you trying this? Okay, let me tell you. So in this, you can see this can be written as 1 by 2 of d of x square plus y square. So any function of x square and x square plus y square will work with this. But in this you need x. In this you need upon this whole upon x square. Then only you can write this. So suppose let's write this x dy minus y dx. See, in the previous example, when you had x square plus y square, it worked because you took x square common, and that you clubbed with x dy minus y dx. Similarly, here also, what you can do, you can multiply with x square plus y square, right hand side and left hand side in the denominator. Why in the denominator? Because then you can take x square common from the denominator, and after taking x square common, you can write 1 by 2 d of, write this left hand side expression as it is, d of x square plus y square upon x square plus y square. Now take x square common, and you can see this x dy minus y dx will become now d of x upon y, and d of y upon x actually. And if you take y square common, then it will be d of, so you can take x square common or y square common, it's up to you, no problem at all. So now it is going to be 1 plus y upon x the whole square, right? So this is function of y upon x, so that will work. You can write this d of, so you can write this d of y upon x divided by 1 plus y upon x the whole square. Now you can integrate, right? So you have d of x square plus y square with a function of x square plus y square, and d of y upon x with a function of y upon x. So both are integrable now. This you can integrate. This is going to be ln of x square plus y square, right? And right hand side, it is going to be tan inverse of y upon x, all right? Yeah, I guess, plus c. So this is your answer. So I hope you got it now. So next sum is, so you have say x cube dx plus y cube dy plus x dx plus y, sorry, x dy. Wait a minute. I need some corrections to do. This is y square, yx and xy, x dy. Then you have x dy plus y dx. Okay, y dx is equal to y upon x the whole square, right? And that is x dy minus y dx. And this is again a very good question. Try this one. Are you getting anything? All right. Well done, Subhash. Your answer seems correct. Yes. Let me solve it now. Then we'll check. Yes. You have written x square plus y square by 2 plus ln of xy is equal to 1 by 2 y upon x the whole square. Okay, it seems correct. Let's check it then. See, yes, you can see xy is common in this. So if you take xy common, it is going to be x dx plus y dy, right? Plus it is d of xy. This is we club with this x dy plus y dx. So this xy, which is written in the first term, in the product of first term, this can be clubbed with this x dy plus y dx is equal to, in this you need x square, right? Yeah, in this you need x square. So it is y square, and write this x dy minus y dx divided by x square. So x square is there in the denominator. Now we'll see if everything becomes perfect. We'll have to divide by xy because this is going to be d 1 by 2 of d of x square plus y square. All right, we'll divide by xy. Let's write it here now. And d of xy is equal to, now this is y square d of y upon x, right? Now if I divide by xy, then everything will be perfect. Why? See, this will be d of x square plus y square. We need to integrate 1 by 2 with respect to d of x square plus y square. So that's perfect. You can integrate any constant. Then you need to integrate 1 upon xy with respect to xy. So that is also perfect. And if you divide xy, then 1y will get cancelled and you get y upon x only, right? 1y will get cancelled and x will be in the denominator, so y upon x, and you need to integrate y upon x with respect to d of y upon x. So this is also perfect. Okay, so now everything is perfect. So integrate this, integration of this, integration of this. So this is going to be 1 by 2 of x square plus y square plus ln of xy is equal to this is y plus y upon x the whole square by 2 plus c. Yeah, so your answer is correct. Perfect answer, Subhash. Good, well done. So this was the answer. Okay, so now I hope you are familiar with this exact forms. Okay, now we are doing some miscellaneous problems today. So this is our first problem. Try doing it, try solving it, then I'll discuss with you after. Are you getting anything? All right. Not getting? Okay. Sufyan, JEE main will be, news is that it will be by the end of February. Sufyan Hebel. It will be by the end of February. That's what we have the news. All right, then let's do it. So if I write like 2x, this equation has 2x e raised to y dy plus, I don't know about boards because I saw the news about boards also. They were saying, yeah, Maharashtra board is shifted in May. But remaining boards, I don't have any other news. They must be shifted by a month at least. If JEE main is, because CBSE conducts JEE main and CBSE is the main board also. So if CBSE will postpone to March or maybe April, yeah, CBSE. CBSE is the conducting body for JEE main. So if CBSE shifts to March or April, they also do the same. It should be in this way only, because now in January JEE main is not possible because they have not given even forms. So it should be by the end of February or maybe more March. And boards should also be shifted by at least a month. At least a month. Yeah, I have. Yes. I can post it here. I can't post it here. 3y square dy. Are you in 12th? Sufyan, I just forgot actually. Are you in 12th? I have, but I do not have any channels. The thing that you are looking for a channel, right? Yeah, so I do not have any active channel like that. 3x squared dx plus 2 e raised to y dx is equal to 0. Personal, okay. That is, wait a minute. Let me check. Because I use Telegram very less, so let me see. Telegram. Yeah, WhatsApp I have. You can note it down. You can share your username, okay? I'll message you. You can share your username of Telegram. I'll message you, okay? So, all right. I'll wait a minute. Let me check first, okay? I'll give you. Wait a minute. Do you have a like? See, have you got the message? S means yes. All right. Now let me give you the solution of this problem. So solution of this problem is, okay, so we'll club the function of x with the function of x only. So let me club these two together. Okay, and this is not a problem, this is not a problem, because we have dy with a function of y and dx with a function of x. So if we take 2 common, this is going to be x e raised to y dy plus e raised to y dx. All right, plus 3 times of y squared dy plus x squared dx. Now see what to do. This is basically d of what? X e raised to y, because if you differentiate x e raised to y, it is e raised to y into differentiation of x, that is dx, and x into differentiation of e raised to y is e raised to y dy. Okay, so you can write like this, and this you can write 3 d of y cube. Okay, 3 also you can club, so that is also you can club. So 3y square dy can be written as d of y cube, right, into 1 plus x square. This can be written as d of x cube by 3. All right, is equal to 0. Now you can integrate. So this is 2x e raised to y plus this is y cube as it is plus this is x cube by 3. Okay, actually you had 3x square. You had 3x square, so okay, 3 will be there and 3 will get cancelled. Okay, yeah. So now you have x cube plus y cube plus 2x is equal to integrating constant x e raised to. So you'll get first option x cube. This is correct. Okay, and slope of tangent to the curve at 1 comma 0. Slope of tangent means 1 comma dy by dx you need. So in the original equation, differential equation, you can put 1 comma 0. So if you put 1 comma 0, it is going to be 2 plus 0 into dy by dx plus 1, so 3 plus 2, okay, is equal to 0. So yes, it is minus 5 by 2. So that is also correct. Sets x-axis at the point at only one point. Okay, so for that, y you need to put y is equal to 0 in this equation. Okay, so put y is equal to 0 to find x-intercept of the curve. So if you put y is equal to 0, it is going to be x cube plus 2x is equal to 3. C was 3, right? So now you can see, yes, that is also correct. So x square, x cube, oh sorry, it is x cube plus 2x. Okay, so we can see clearly, we can see one is one of the solution, and yes, it should be, because curve is passing through 1 comma 0. So if you take x minus 1 common out of this curve, then see the remaining quadratic x square x cube, and I'm trying to factorize it, minus x square, and then x minus 1 plus x square minus x, and then again x minus 1 minus x. We need 2x, so plus 2 plus 3, sorry, is equal to 0. So it is going to be x minus 1 into x square plus x plus 3. Okay, so this has no real solution, so you have only one solution, x is equal to 1. So at only one point, that is also correct. Okay, so this is also correct option. So I hope it is clear. Now we have another equation. Where are you from, Sufyan? I forgot actually. You told me once, I think. So now we need to write general solution of the differential equation. This, okay. This is easy to solve, it seems. Try this one. I hope you would get it. So now you can see that there's a function of xy, e raised to xy, and there's a function of x upon y also. That means you need to make exact form of d of xy and one more exact form, that is d of x upon y. Why? Because in that case you can club e raised to xy with d of xy and e raised to x upon y with d of x upon y. So to make d of x upon y, you need y dx minus x dy upon y square. Okay, and to make x d of xy, you need x dy plus y dx. All right, so let's solve it then. So if we solve it, then it is going to be xy square e raised to xy into dy plus e raised to x upon y into x into dy is equal to, first I'm just expanding all the terms, so y e raised to x upon y dx minus y cube e raised to xy d of x. All right, now you can see they can club which term, xy wale term. So this is term with xy and this is also the term with xy e raised to xy. So club these two terms and take common whatever is common. So you can see y square is common. Okay, so y square is common. All right, e raised to xy is common and it is going to be x dy plus y dx, and actually it should be, because we can write this d of xy. And the remaining two terms, let's take this to right hand side. Okay, so and take common whatever is common. So e raised to only x upon y is common and it is going to be y dx minus x dy. So it's going perfect. You just need to divide it by y square, right? So yes, it is written here, so just divide it by this. So it is going to be e raised to xy d of xy, and if you divide by y square, then it's going to be e raised to x upon y d of simply you can write x upon y. Okay, now you can integrate. It's like t dt. So integration of t dt. So integral of t dt is nothing but t square by 2. So it is e raised to xy the whole square by 2 and is equal to, it is e raised to x upon y the whole square by 2 plus c. Okay, so that is going to be the answer. All right, that is going to be the answer. Now we have another question. Try this one. We'll practice a lot of good sums today. Differential equations, we'll finish it now. So all the good sums I've collected to discuss today. Will be slightly longer session. All right, so let me solve it then. It is if we cross multiply, then we'll get 2x cube y square y cube into dy plus x dy is equal to y dx minus 3x square y cube dx. All right, so you can club these two terms. Clearly we can see y dx minus x dy, and then divided by y square you can do, and club these two. Okay, so let's see. You can see y square is common in the first and last, left side, leftmost and rightmost I'm talking about. So you can take y square common. Okay, that y square will go with this, and remaining let's write like this: 2y x cube dy, and this term if you take y square common, it is going to be plus 3x square y dx. Yes, is equal to y dx minus the y dx minus x dy. Okay, now if you see, you can write like this. This sum can be written like x cube into differentiation of y square. 2y dy means d of y square, plus this can be written as y okay, it was y raised to 4. Yeah, this was y raised to 4 actually. This was y raised to 4. So if see, this y into y cube is y raised to 4. So if y square will be remaining here, yeah, y square. So it is y square into d of x cube. 3x square dx can be written as d of x cube. Okay, is equal to y dx minus x dy divided by y square. Further, this left hand side expression can be written as d of x cube into y square, because you can see this is u into v formula, right? And right hand side it can be written as d of x upon y, d of x upon y, right? Yes. So finally, it is going to be x cube y square is equal to ये आ जाएगा x upon y plus c. All right, it's like this. This is the answer. This is the solution. So you can see this is the solution. Today's 25, 26, 27. Now let's do another problem. This one. I hope the last one is clear. equation of the curve passing through 1 comma 1 and satisfying the differential equation x y square plus y square plus x square y plus 2xy into dx plus 2xy plus x square in the whole into dy is equal to 0. This is not homogeneous equation. You can check whether it is first order linear differential equation or not. And after checking all these things, you can finally, in the beginning also, if you have so many terms, okay, then you should think of exact form, okay. You should think of exact form. That will make the question easy. So try this one. Let's solve it then. So now let's think which term should be clubbed with which other term. So it is like if you multiply it is x y square dx plus y square dx plus x square y dx plus 2xy dx, all right, plus 2xy dy plus x square dy, all right. Now see which two terms can be clubbed. X y square dx, okay, and 2y dy wala term, this one, okay. Yeah, these two can be clubbed together. So this can be written as, okay, let's write them together, x y square dx plus this is x into 2y dy, okay. Yes. Okay, what was that? X y square 2y dy plus, okay, yeah, and then you can club x square y dx and yeah, these two. So these two can be clubbed together, x square, in a minute, yeah, y dx and 2x y dy, 2x dx. No, sorry, not this one. This term will be clubbed with, wait a minute, Yeah. So this 2xy dx, this term can be clubbed with x square dy. Yeah, these two. So it is going to be y square dx. X square y. Oh, there's something I'm missing. Something. What? 2x dx and x square. Yeah, yeah, it's perfect. Yeah. This is 2x square dy plus 2xy dx. That is right. What was the first term? Xy square, and then it was x as it is. In this there was some problem. First pairing was wrong. First pairing should have been of 2xy dy with y square dx. Huh? Yeah. First pairing was wrong. That's why I was confused. First pairing should have been of y square dx and this one 2xy dy. Huh? So y square dx plus x 2x y dy. Yeah, these two. So we have clubbed this second term and second last term, and fourth term with fourth last. Okay, now two terms are remaining. Which two terms are remaining? So you can see terms are remaining: x y square dx plus x square y dx. All right, let it be like this. We can take xy common if required, but we'll see if that is necessary. Now, what can this be written? This can be written as d of, this is a difficult question actually, yeah. So this is d of xy square, right? D of xy square, yes. D of xy square, fine. Plus the second one is d of x square y, all right? D of x square y. Plus you can see this is xy square, dx. It's a very, very good question. Plus x square y into dx. Now see, this is like, let me club this term and xy square, where's xy square? This term, okay? So this is d of xy square plus xy square dx. It is like dt plus t dx, dt plus t dx, okay? Or you can say dt by dx is equal to t. So to make this exact, you need to multiply it by integrating factor. I'll tell you what. Now you can club the remaining two. So d of x square y plus x square y dx, okay? So I'll have to give this example to you first. If you have like dy plus x dx, okay? Something like this, dy in x dx, yeah. Plus y dx, I'm sorry. We have dx, dy plus y dx. Then you can make this exact form if you multiply it by e raised to x. If you multiply it by e raised to x, dy plus y e raised to x dx, okay? So this is going to be your exact form. So similarly, in this, to make it exact, you need to multiply it by dx. In this also, you need to make it exact form. You need to multiply it by dx, e raised to x. Sorry. So this whole equation should be multiplied by e raised to x. If you multiply it by e raised to x, then right hand side it is 0, so no problem. So you can multiply e raised to x d of, this can be written as d of y e raised to x, okay? So to follow this, we are writing e raised to x d of x y square plus e raised to x plus e raised to x y square dx. All right, there's, now you can see there's a u into v formula. differentiation of u into v. And similarly in this also, e raised to x d of x square y plus x square y e raised to x d of x is equal to 0. So now this can be written as d of e raised to x into xy square, plus the second can be written as d of e raised to x square y is equal to 0. Now you can integrate. Oh, so this was a very, very good question. I mean, difficult one. So now you can write e raised to x xy square plus e raised to x square y is equal to c. All right. Now this is the final solution. So this is the final solution. All right, so I hope it is clear. Now let's move to another problem. This one. Solve it. Sorry, this one. It seems a good question. So if I write this is like e raised to x upon y minus xy, right? If you multiply xy, now if you open the brackets, it is going to be x upon y minus. So you can separate e raised to x upon y into e raised to minus x upon y, right? Similarly here also you can write y dx minus x dy divided by you multiply this whole equation by dy, okay? So plus y square you can take common, and it is going to be x dy plus y dx. Yeah, so now it is visible what is happening. You need y square in the denominator of first term, so divide this whole equation by y square, and also separate these terms. It is e raised to x upon y, and it is e raised to minus x upon y, okay? This is d of, okay, okay, I'll write one more step, y dx minus x dy, this is x dy, x dy whole divided by y square plus this is d of xy is equal to 0. Okay, so now you can write e raised to x upon y as it is, and you can write this whole term as d of d of x upon y. Yeah, plus you can divide by e raised to minus xy, so it is going to be e raised to xy here, and this d of xy is equal to 0. Now you can integrate it. So integration of e raised to t with respect to t is e raised to t only. So it is going to be e raised to x upon y only. Similarly, e raised to integration of, again this is same as in e raised to t dt. So it is e raised to x y only, and plus integrating constant is equal to 0. So that is the answer. Okay, no problem. So I hope it is clear. Now next, let me move to next one. This is our next problem. Try solving it. Alright, so let us solve it. So it is, you can take x, okay, x square dy minus 2xy dx is equal to x cube y cube dx plus x raised to 4 y square dy. All right. So now you can see which term you should club. Let's see. If you take x cube y cube common in this, then it is going to be um, all right. So let's club some terms. If you take x common, then it is going to be x dy, and then okay. So now it is very essential to seek some terms in which you can club. Just keep looking for it. Alright, so if you see this, x squared dy minus 2x, so this is differentiation of x square, right? And y dx, and this is differentiation of y. So if I see like this, u into differentiation of y into differentiation of x minus x into differentiation of y divided by y square, then this can be written as d of x upon y, right? So if you divide by x raised to 4, square of this, right? Square of this term, then it is going to be, see, I'll divide by x raised to 4. And here also I'm going to divide by x raised to 4. So it is going to be so it is going to be d of what? D of y upon x square. Yeah. So let it be like this. And right hand side, if you cancel x raised to x cube, at least you can cancel. And y square, okay, take x cube, x square, y square, you can take common x square, y square. So it is going to be y square upon x square, okay? If you take x square, y square common, so it is y dx. You should take x cube common now. X cube y square, x cube y square, x cube. So one more x, okay? So y dx plus x dy, okay? Like this. So now one more x you can cancel. So it is actually or let it be like this only. Okay, so remaining terms I'm writing y square upon x is remaining, and this is d of xy, right? So with this you can keep only terms with which are function of xy, and with this you can keep function which are of y upon x square type, okay? So y upon x square type, okay, you can what you can do is you can multiply and divide by x, so which actually you cancelled earlier. Now I'm multiplying, dividing by x again. So what you can do, you can write this term as y upon x square, which I'll take to left hand side, and 1xy, which I'll keep it here, which I can integrate with respect to xy, right? So now I can write d of y upon x square divided by y upon x square, all right, is equal to this is d of xy into xy, all right? So now you can see after integrating it, it is ln of y upon x square is equal to xy the whole square by 2 plus c. All right. So this is what we are getting. Okay, so I hope it is clear. Now let's move to another one. Not this one. We'll solve this one, okay? All right, so let's start with this. It is written x raised to 4 y square dx minus y dx plus x square y cube dy minus x dy is equal to 0. So now you can see you have, okay, let's club this second and fourth and first and third, of course. So in first and third, whatever you can take common, take common. So what should you take common? Let's take x square y square common, although yeah, x square y square common. Now it is going to be x square dx plus y dy. Okay, that's fine. That's fine. We can integrate these terms. And x square y square can be clubbed with this x dy plus y dx. All right, perfect. So it is x square dx. Write this as independent term. We have function of x with dx. So that's all right, integrable. Then we have function of y with dy. So it is y dy minus this is d of xy divided by xy the whole square, all right, is equal to 0. Okay, so yes, this is what we are getting. Now you can integrate it. So after integrating it, you can get x cubed by 3 plus this is going to be y square by 2 and this is going to be 1 upon integration of 1 upon x square is minus 1 upon x. So it is 1 upon xy, okay, and is equal to c, integrating constant. So that is going to be our answer. Now you can check. So it does some problem. Maybe we copied something wrongly. Yeah, actually this was y raised to 4. Okay, this was y raised to 4, so there's one correction. Y raised to 4, then this will be y square and this is y square, so it will also be 3. Okay, yeah, now it's perfect. So you can multiply by 3 and sign also. Yeah, there's problem of sign. Let me check. No, this is plus sign, yeah. So yeah, option C is correct option. Now you can multiply it by 3, so it is x cubed plus y cubed plus 3 upon xy, And this 3c can be written as new c, okay, new c. 3c or c by 2 or c cube can be written as c dash new c. C is not a problem, okay. So this was the problem. Now we have another question is this. Let me check. This is done. This is let's do this one, huh? Yeah. This is not x, this is not x. Don't get confused. It is y double dash is equal to 2y dash square. Okay, it is written like this. This is not x. It's into 2 into y dash square. Yeah. So it is like y double dash minus y dash square is equal to y dash all right. Now you can divide by this. So you can write y double dash minus y dash square divided by y dash square is equal to 1. All right. Then you can see what is this, like first into differentiation of second, u upon v formula. So u upon v formula, denominator into differentiation of numerator minus numerator into differentiation of denominator. So you'll have to take minus common here. So minus common, so they keep minus here, plus here, and then minus right hand side also. So denominator into differentiation of numerator, so it is differentiation of d of y upon y dash. Okay, now you can see this. This is equal to, and upon dx you can write, so this is minus dx, okay. So ddx you could write ddx. So dx I have sent to right hand side. Now you can integrate it. So after integrating, you'll get y upon y dash is equal to x minus x plus c minus x plus c, okay. Minus x plus c, okay. Now to find c, it is given that y dash 0 is 4. That means you put x is equal to, this is y of x, this is y dash of x, okay. So if you put y 0 in this, then you'll get 1 in the numerator. Y of 0 is 1, y dash 0 is minus 4, so minus 1 by 4 is equal to 0 plus c, so you'll get c, okay. So in this way you'll get yx, yx means y upon y dash is equal to this is minus 1 by 4, so minus x minus 1 by 4, okay. All right, so I hope it is clear. Now you can write dy by dx, huh? So you can write dy by dx upon y, just take the reciprocal, okay, and it is going to be 4 upon minus 4 upon 4x plus 1, all right. So you can write dy upon y is equal to minus 4 dx upon 4x plus 1, and again you can integrate, so it is ln of y is equal to minus 4 ln of 4x plus 1, all right, plus again integrating constant, yeah. See if everything is all right. Y double dash is equal to y, yeah, seems. Now you need to find c again. So x is equal to 0, y is 1 given. So if you put x is equal to 0 again in this will become 0, and y of 0 is 1, so this will become 0. So c comes out to be 0, okay, in this case. So finally you will get this, y is equal to, ln y is equal to minus 4 ln of 4x plus 1, all right. So you can write y is equal to 4x plus 1 raised to minus 4. Okay. This is what I'm getting. This is what I'm getting. Yeah. Okay, this I have done without this x, okay, without this x. Okay, so y of x here belongs to 0 to infinity, and all these options you can check now. So I think in this question x was there, okay, because this is a solution without x, so that was not multiplication, actually that was x. Yeah, so original question was like this, y double dash is equal to 2x y dash, because if I see the solution of this, then this is not matching with any of the options. That means I wrongly took this as a multiplication symbol. It was written like that, so I thought, okay, it is actually yeah, so I'll correct it now. I'll write it again. Okay, so this was like y double dash is equal to 2x y dash square. Now I need to subtract y dash square again, so okay, and divide by y dash square. So I'll do like this now. This is y double dash y dash square is equal to 2x y dash square minus y dash square, and then you divide by y dash square, and also with minus sign. So you can write y dash square minus y double dash divided by y dash square, and right hand side it is going to be minus 1 minus 2x, actually 1 minus 2x. So this is d dx of, actually same thing, this is same. Now the function right hand side is changed now, y upon this is y upon y dash, right, derivative of this is equal to 1 minus 2x. So now it is y upon y dash d of this is equal to 1 minus 2x dx, all right. Now you can write y upon y dash is equal to, if I integrate it, it is going to be x minus x square, right? Yeah, plus c. And now if I put x is equal to 0 in this, then c is going to be same thing, I think. Yeah, y of 0 is 1, y dash of 0 is minus 4 is equal to 0 plus c. Yeah, so c is going to be minus 1 by 4. Now okay, so now if you write y upon y dash, this is going to be x minus x square minus 1 by 4, all right. Okay, now if you take also okay, so this is if you take LCM, it is going to be if you take minus sign common in LCM, so it is 4x square plus minus 4x plus 1 divided by 4. Okay, so you can write dy by dx is upon y is equal to 4 upon 2x minus 1 the whole square with minus sign. I hope see this is all right. Yeah, seems all right. Now you can integrate, so 1 upon y dy is equal to minus 4 dx upon 2x minus 1 the whole square. So it is like 1 upon t square. We can integrate it. So it is ln of y is equal to minus 4. Integration of this is 1 upon x square. Integration of 1 upon x square is minus 1 upon x. So it will be 1 plus 1 upon x is 2x minus 1. And you need to divide by 1 by 2 also. Yes, it is going to be like this. So finally it is going to be 2 upon 2x minus 1. All right, I can see that. Okay, now I'll write it here. So y is an integrating constant as well. Yeah, integrating constant. So we need to find integrating constant. Y of 0 is given 1. So if you put x is equal to 0 in this case, so this is going to be 0 and this is going to be if you put 0 minus 2 plus c. So c is equal to 2 now. So if you put c is equal to 2, so ln y is going to be 2 upon 2x minus 1 plus 2. So it is going to be ln y is going to be 4x upon 2x minus 1, and then you can write now you have got the function y is equal to in terms of e raised to something that was given in some options, 4x upon 2x minus 1. So yes, y of 1 you can check is equal to e raised to 4. That's perfect. And y of 2 you can check. Y of 2, if you check it, is y of 2 is also actually e raised to 8 by 3. That is also good. And you need to find the range of this. So that means you need to find the range of 4x upon 2x minus 1 first of all. And then you can find the range of this function. So if you find the range of 4x upon 2x minus 1, it's a good question actually. It's slightly difficult also. Minus 2 plus 2. Then is 2 plus 2 upon 2x minus 1, right? Can we write like this? Yes, we can write like this. And the range of 2 upon 2x minus 1 is actually so range of this function is it's a hyperbola. It's a hyperbola. So x minus 2. Its range is y r minus 2. Its range is r minus 2. Okay. So hyperbola, its range is r minus 2. Only 2 will not occur because this cannot be 0. And otherwise it can take all the values 2 upon 2x minus 1. So range is r 2x minus 2. So its range of e, okay, yeah. So this can take all the values, this y e raised to 4x minus 2x, the power which is power of e can take all the values except 2. Okay, so if range of e raised to x is 0 to infinity, but if x is equal to 2 is missing, if 2 is missing in the range, missing in the inputs of e raised to x, then e square will be missing. So range of ex is going to be 0 to infinity minus e square. Okay, why e square is missing? Because this value cannot be 2. Because this value cannot be 2, so e square will not be in the output. And remaining outputs will be there. Remaining output means outputs of e raised to x will be from 0 to infinity, right? E raised to x gives positive outputs only. So 0 to infinity. So it's a very, very good question and slightly difficult also. Not slightly, in fact, it's a difficult one. Okay, so all right, so we'll end this session here. We have completed differential equations. All right, so let's put an end to this session. I hope you enjoyed differential equations. Okay, I've covered all the methods to solve differential equations, and in today's session we have discussed really very good questions of exact forms. Okay, so if you do all these questions and if you learn the method, then it is really going to help you in differential equations. Okay, and this method is beyond any other. This is applicable in any type of equations like variable separable, like homogeneous equation, like first order linear differential equations. In spite of learning all those solutions, you can apply this particular method exact form anywhere. Okay. All right, so thank you very much. We'll continue straight lines from next session. Okay, thank you again. Like and subscribe the channel and use my code JEET1 if you are planning to subscribe on Academy Plus. Thank you very much once again.